Hello again. In this video, I'm going to go over this homework problem from section 3.4. So in this problem, we've got two parts. The first part says for this function 8 over x, we're supposed to find an equation for the secant line through the points x equals 5 and x equals 8. Okay, so let me show you how to work this out. So first of all, we're going to need the slope of the secant line that goes through these 2 points, and we can find that using this formula. The slope of the secant line. Now in this case, it doesn't matter which one you call A or B. So I'm just going to call this one A and this one B. Okay, so we end up with F evaluated at 8 minus F evaluated at 5 all over 8 minus 5. And then F of 8, we can plug that into the function, and you can see that you get 1 out. And then F of 5, you get 8 over 5 out. Okay, so this becomes 1 minus 8 fifths on top, and on the bottom, that's just equal to 3. Okay, and so of course here we're going to need a common denominator in order to subtract these. So let's write this as 5 over 5, which is equal to 1. Then we can subtract this fraction. So we get 5 minus 8 is negative 3 fifths, all divided by 3. And I'm going to think of it as 3 over 1. 3 is the same as 3 over 1. But now that you're dividing a fraction by another fraction, you can flip this one and multiply by it. So it's really negative 3 fifths times 1 over 3. And then notice that the 3's cancel, and so you're just left with negative 1 fifth. Okay, so that's the slope of the secant line that goes through these 2 points, okay, for this particular function. Okay, now let's use the point slope formula for the equation of a line to actually find the equation of this secant line that goes through these 2 points. Okay, so we know the slope has to be negative 1 fifth. Then we just need 1 point on the line, x1 comma y1. And we actually can find 2 different points here. You can use either one. One is certainly when you plug a 5 in, you get 8 fifths out. And the other one is when you plug an 8 in, you get a 1 out. And I think I'd rather use this one because this one has fractions. Okay, so let's call this one x1, y1. That doesn't matter. You could use this one for x1, y1, and you'll get the same answer. But I think this might be a little bit easier because it doesn't have fractions in it. Okay, so we end up with x minus x1, and x1 is 8. And then over here we get y minus y1, which is 1. Okay, and then let's just kind of clean this up a little bit. I'm going to distribute the negative 1 fifth. Now notice here you're going to get a plus because you have a minus times a minus, and it's going to be 8 over 5. And then now we just need to add the 1 to the other side, or to both sides really. Of course, when you add these together, you're going to need a common denominator again, so I'm going to actually write that as 5 over 5. Again, that's the same thing as 1. Now that we have a common denominator, when we add these, we get 13 fifths. Okay, plus the negative 1 fifth x. And that's the equation of the secant line that goes through these 2 points on this function. Okay, so that's how you work out part A. On part B, we're supposed to find the equation of the tangent line that goes through this 1 point, x is equal to 5. So what's a little bit different about this is the slope of the tangent line is given by this formula, which is a limit. Okay, and so we need to find that first, but once we find the slope of this tangent line, then we can just use the point slope formula to find the equation of the tangent line. Okay, so let's find the slope of the tangent line first using this formula. Okay, so in this formula, the a is equal to 5 in this case, because that's the point at which we're trying to find the tangent line to this function. Okay, so that's going to be f evaluated at 5 plus h minus f evaluated at 5, all divided by h, and then we're going to find the limit of that as h goes to 0. Okay, now I'm going to go ahead and find f of 5. F of 5, you can see, is just going to be 8/5. Okay, so that's pretty straightforward. But finding f evaluated at 5 plus h is going to require a little bit more work. So I'm going to do that over here on the side. Now, in order to find this, we have to plug this into this function. And when we plug it into the function, we get 8 divided by 5 plus h. And so the way this works is no matter what you plug into this function, whatever the input is, the output is 8 divided by whatever you input. And this is the thing we're inputting, so it's going to be 8 divided by that. Okay, so that's what we get out of this part. Okay, we input a 5 plus h, and we get this out. Okay, and then this is all divided by h, and again we have to find the limit of this as h goes to 0. Now initially when you look at this, we might try direct substitution to evaluate this limit, but notice when you plug a 0 in for h here, you get 8/5 minus 8/5. So what that's telling us is that as h is approaching 0, this top part is approaching 0. Of course, so is the bottom part. And that means we have an indeterminate form. And so we need to change the form. Anytime you have an indeterminate form, you have to change the form to a determinable form. And when you have fractions, typically the way you do this is you try to get a common denominator. Okay, so let's try to get a common denominator here. So between 5 and 5 plus h, the least common denominator is simply 5 times 5 plus h. And so you can see that this fraction over here is missing this factor of 5. And so I'm going to force that in by multiplying it by 5 over 5. Now, of course, it's perfectly legal to do this because 5 over 5 is equal to 1, and I'm not changing the value of this fraction. I'm just changing the way it looks. So over here, we're missing the 5 plus h, and so I'm going to force that in, again, by multiplying by 5 plus h over 5 plus h, which again is equal to 1. Okay, so now we have a common denominator here of 5 times 5 plus h. And then notice on the top here, we're left with 40 minus 8 times 5 plus h. Okay, and then this is all divided by h, and we still have to find the limit of it as h goes to 0. Okay, so let's clean this up a little bit. Let's go ahead and distribute this negative 8 to both of these. So that's going to leave us with 40 minus 40 minus 8h. Okay, so you distribute it to here and you get minus 40, and you distribute it here and you get minus 8h. And then that's divided by this common denominator, which is also divided by this h. Okay, so notice the 40s cancel out. And that's going to leave you with a minus 8h on top. And then we have this h on the bottom still, but I'm going to think of it as h divided by 1. Now the reason I want to think of it that way is, well, first of all, h divided by 1 is still equal to h, but now you have a fraction divided by a fraction, so you can flip this bottom one and multiply by it, okay? So this is equal to minus 8h divided by that common denominator, and then times the reciprocal of this bottom fraction, which is 1 over h. Okay, so notice that if you try to use direct substitution to evaluate this limit, you would still get 0 divided by 0, which means it's indeterminate. But since these h's cancel, right, once you cancel these h's, that's when it becomes determinable, right? You're left with this limit. Okay, now we try direct substitution after we've canceled the h's, and we no longer get 0 over 0. Notice that this is getting closer to 0, right? So as that happens, this is getting closer to 5 plus 0, so that's getting closer to 5, which means this bottom piece is getting closer to 5 times 5. So overall, it's getting closer to negative 8 over 25. Okay, and of course, remember, this is the slope of the tangent line to this function at this particular point, x equals 5. Okay, so now that we know the slope, we just have to plug that into the slope down here in the point slope formula. And then again, we just need 1 point on the line. And so we know this goes through the line, right? And so the point would be 5 comma 8/5, right? This is the x value, the y value would be 8/5. Okay, so I'm just going to plug that in for x1. x1 is 5, and y1 is 8/5. Okay, so we're almost there. We just need to clean this up a little bit by distributing the negative 8 over 25. So distribute it to the x, and you get this, and then distribute it to the 5. Of course, you get a negative times a negative, so it's going to be a plus. And then 8 times 5 is actually 40. So you get 40 over 25. And now just add 8/5 to both sides. Just to get y by itself. Okay? And so you can see you're left with a y on the left, and then minus 8x over 25, plus we need a common denominator here to add these. So let's actually write this. So we need a factor of 5, right, to get a denominator of 25 here. So we're going to have to multiply this by 5 over 5. Again, that's equal to 1, so it's perfectly legitimate to do that. And so notice that you get 40 over 25. Okay, so I'm just going to write that as 40 over 25. Now notice 8/5, I added 8/5 to both sides. 40 over 25 is equal to 8/5, right? You can reduce this to 8/5. So I'm adding the same thing to both sides. But again, I need to write it like this so I can have a common denominator. And so it appears that you get 80 over 25. Okay, and you might be able to reduce this some. So they certainly have a factor of 5 in common. So I believe you can write this as 5 times 16. So 5 times 16 is the same as 80. And of course, this is equal to 5 times 5. And so those 5s will cancel out. Okay, and so if you want to reduce that, the slope of the equation of the tangent line is minus 8x over 25 plus 16 over 5. Okay, so that's how you solve part B of this problem. Now notice part B and part A are fundamentally different in the sense that in part A you were trying to find the slope of a secant line that went through 2 points on the function. And so we had a formula to find the slope of the secant line, f of b minus f of a over b minus a. But in part B, we're finding the equation of the tangent line, so we had to use this formula, this limit, to find the slope of the tangent line. But after we found the slope in either case, we used the point slope formula for the equation of a line to actually find the equation of the tangent line or the secant line. Okay, so I hope you found this video helpful. Thank you for watching. Bye.